Ready?
Good to go.
Okay, so this is our official welcome. My name is Bob Henderson. I'm actually broadcasting from Raleigh, North Carolina. We have a rain today, a rainy week, but we're glad to be here.
My name is Ben Coyle. I'm coming to you from just north of Boston.
And Colleen McLaughlin, I'm in Bergen County, New Jersey.
Okay, so we have been looking forward to this session for a while, and we're going to talk about the easy design practices that it takes for lighting it correctly, or we call it lighting right. So as we begin this, we're going to start. And we would like to also now welcome who just popped on, Donald Andrews. Donald is our studio design manager, and his expertise is focused on outdoor lighting. So Donald, welcome. Say hello to everyone.
Hi, I'm Don Andrews. I'm in Sussex County, New Jersey, and we're having a nice sunny day out here and happy to be here.
Okay, so I'm still working on the slide advancement here, and not advancing. So Ben, if you would go ahead and go to slide number 1.
You're good to go, Bob.
All right, so here we go. Let's try it now. Yeah, still, okay, so here we go. So our 3 top takeaways that we talk about when we enter into a webinar, these are the things that we would really love for you to take away today as we talk about these design practices. So easy design practices will help you use RAB products correctly, and it also reduces callbacks. The number 2 session or a thing that we'd like to take away is proper fixture spacing, aiming, and mounting height will contribute to cost savings and lower energy use. And we'll talk about how that works. And the third thing is using appropriate bug ratings, glare control, equivalency, and overlap will enable you to light it right. So with that, here we go. And so what we're going to do is I'm going to present some and ask Donald some questions, and we will be teaching in a back and forth interactive manner today. So we've done this before on some other lunch and learn, so it's always a lot of fun. So we have this broken down today into area lights, wall packs, flood and spotlights, and outdoor bug ratings. And you can see the subcategories that we have for each one of these. So under the area lights, which is our very first one, we're going to talk about pole and fixture spacing and mounting heights. All right, so as we get into the area lighting, let's go to our first one, and we'll see we have a lot of different products here from RAB, the Lot Blaster, which is our economy, the Ive Lot, the ALED, the Yard Blaster, and the ALED. So all of these are different, and they can be used in different ways. So what we want to do is first introduce you to the IES Luminaire classifications. So these classifications are used for roadway and area lighting, both types of luminaires, and the type describes the distribution and the pattern on the ground. So Donald, I'm going to ask you if you would to come in and just briefly give us an overview of type 1 through type 5S, please.
Sure. So the type 1 is a narrow, very long spacing from pole to pole distribution that is used largely like in center islands for roadways, this type of thing. This is not a distribution type that RAB offers, and it's used primarily in roadway lighting applications. The second one, type 2, is similar, but there's a little bit more forward throw to it. It pushes the light out a little bit more to one side in front of the fixture, and it still has a very long spacing between fixtures. Then we have the type 3, which pushes a little bit more light out to the front of the fixture, shortens up the sides a little bit, is what you would call a middle of the road distribution. It's used in roadways, it's used in parking lots, it's used everywhere. It's probably our most popular distribution of all of them. We use this for everything. The type 4 is a forward throw. This image down here doesn't do it full justice. It really maximizes the light going forward and shortens up the distribution side to side. So as the narrowest, I should say it has the shortest spacing side to side, but you'll use this on perimeter of parking lots and other areas where you need to really throw light out a good distance. And then you've got the type 5s, and the type V, the type 5 with the V is just a symmetrical circular distribution, and the type VS stands for square, and that's a nice square symmetrical distribution. You'll find those in the middle of parking lots where you're trying to light from a single fixture in all directions.
Okay, so there's a big difference between a 3 and a 5 or a 5S. There's a difference between a 2 and a 4. So it's really important that you pay attention to this when you order the fixtures, when you do the design, when you do the rules of thumb. So here we go with some applications of this. So the first type we're going to talk about is our type 2. Now, Donald just said this was a very long, narrow, maybe a pathway, a two-lane road. So what we're going to do is introduce to you some guidelines here. So for the type 2 going far up and down, you can think the X here is the mounting height that at the bottom. So 3 to 3.5 on one side, and then always on the other side also. And so in between poles, you have a 6 to 7X mounting height, very far light throw up and down the roadway. But look across, it only has 1X. Okay. Now, let's go from a 2. Next one is a 3. So, Donald, tell us what happens when we go from a 2 to a 3. The numbers just change. Please explain that for us.
Sure. So we're shortening up the side-to-side spacing, and we're pushing more light out to the front. So if you think about the output from a fixture, the amount of light you can get out of the fixture is pretty constant from the source, but we can shape it as it comes out of the fixture to either go side to side maximum or go to the front maximum. And so it's shortening up the sides, it's pushing a little more out to the front. So our spacing went from 6 to 7 times down to 5 times the mounting height. And one of the things that I want to make a point about in terms of mounting height, we're talking about all this stuff in terms of mounting height, and it really goes to the essence of what this whole thing is about, which is if you're out in the field and you're looking at pole spacing, or somebody calls you on the phone and they want to talk about pole spacing or whatever, and they say, I want to provide light from here and I want to project it out 200 feet. The first thing you do in your mind, you say, okay, what's your pole height? You divide that 200 by the pole height and you go, that's 6 or 8 or 10 times the mounting height. We can't do that. Physics doesn't allow that. And so that's really, this is like a gut check for any time you're doing something is, am I basing this off of reality? And that's kind of why we're going through these various scenarios here with you.
So this is our one of our foundation blocks. So just so everyone is on the same page, let's just assume we had a 10-foot mounting height. So you see the 5X. So that would mean 50 feet between the two poles, and it would be 25 feet to one side to the left, and then over on the second fixture it'd be 25 feet to the right. So that's what that means. That's how you apply this.
Exactly.
Okay. All right, now let's go to 4. So now we're even squeezing that light forward just a little bit more. So would you comment on that one, Donald?
Sure. And this one is, the other thing to keep in mind is that all of these are very general descriptions of the distributions. Every product, every manufacturer's fixture, everyone is going to be slightly different. So when we talk about these are very general guidelines. But for the type 4, we're saying that a really good distribution, you're going to get 3.5 to 4 times the mounting height out to the front. So if I've got a 30-foot pole and I can go out 4 times the mounting foot height, that's 120 feet out. If they're asking me to do 200 feet, I can't do it. Side to side, if I'm going 4 times the mounting height, that means that I'm going to go 120 foot between spacing between poles, and that's the extremes. So we may be a little bit less, and that's where you really need to do a lighting layout. But that kind of, these are outer limits. These are guidelines.
Yes, good. Also, what this also means is these guidelines are kind of to provide adequate uniformity. So
Exactly.
as we describe this from the IES, they're saying for parking or for area lighting, we consider this acceptable uniformity with these guidelines. Okay, so a good application for a forward throw would be like if you have perimeter pole locations only and you have a far distance across, then a forward throw type 4 would be probably what you would need to use because you need to throw that light forward and you can't get in the middle of the parking area to do that. So, okay, now let's go to a 5. So, Donald, you talked about this earlier, but this is symmetrical all the way around, please.
Right. So, I'm in a center island in the middle of a parking area, and I'm trying to provide as much light as I can. And I can go with 2 type 3s back to back, and that's 2 fixtures. Or I can look at 1 type 5, which is going to distribute pretty much to the same coverage as the 2 type 3s. And so to the extent that I have a good performing type 5, I can get really good uniformity, cut the number of fixtures in half, and lay this out so that my like 0.5 foot candle lines overlap. Now, the one question is that has come up in the past is, well, where would you use a round one versus a square one? And I will tell you that the square one lays out very well. Bob has a great anecdote about this, and I'll leave it to him to share. But there are times when the round one is the appropriate. It really depends on the shape of the layout, and I'll throw it back to Bob for that.
Okay, so yeah, we talk about the square. So many of our parking lots are square. And so if you think about this, everyone is eating a Wendy's hamburger. So we know that the shape of that patty is square, it's not round. So Dave, when he came up with this, he cooked those hamburgers on a square or rectangular grill. So this is what Don was talking about. The light pattern is square. Yes, it's still symmetrical, but it's more in a square shape. So you're really putting the light exactly where you need it into that square shape of that parking or area that you're lighting. Okay, so now let's talk a little bit about mounting heights. I know whenever we get requests in lighting design, I think one of the main things that we struggle with sometimes that's left off of the request is what is your mounting height? Mounting height makes a great deal of difference. So you'll see there's different lumens and different wattages associated with different mounting heights. You don't really want to put a very high lumen package in a low mounting height. Conversely, you don't want to put a very small lumen package in a high mounting height. So you see these guidelines here, 10 to 15 feet. You're looking at 3,500 to 5,000 lumens. There's the wattage, 50 to 75. Go to the medium, which is 20 to 25. You've got 5,000 to 17,000 lumens. Now these are delivered lumens from an LED fixture, okay? 78 to 150 watts. And then over on the high side, you'll see the 17 to the 37,000. It goes all the way up to 360. Dolly, you want to comment on an application maybe where you may have seen one or the other that just if these guidelines had been followed, would have been better off, and you had to correct this?
Sure. One of the big challenges is, and I was guilty of this for the first many years of my lighting career, was not really understanding the impact of high wattage fixtures on low mounting heights. And if you put a 400 watt metal halide or 400 watt high pressure sodium on a 15 or 20 foot pole, you're going to have a really bright hot spot. It will light up the area that you're trying to light, but you've got more light than you need. You're wasting light, and you're also introducing a lot of glare, and you're making it difficult because of adaptation for people to see clearly, because the bright areas are way brighter than the dark areas, and so your eye can't adjust properly. So one of the benefits of LED is that because you can control the distribution of the light as well as you can, and you can reduce the hot spots, it becomes a real beneficial thing to get the right lumen package on the right mounting height. So if I put a 78 watt on a 20 to 25 foot pole, I'm eliminating the hot spot for the most part, and I'm getting the widest distribution that I can for that output, and I'm being as efficient as possible. And so that's really the benefit of trying to size the fixture to the right height pole.
Okay, great. So the thing to remember from that is we want to make sure that we don't put too many lumens in a low mounting height. If we want more light, the first thing we should ask is, should I raise the mounting height? So I'm going to turn this back over now to Ben, and Ben is going to take us through our wall pack.
All right, so we actually have quite a few wall packs. Those of you who have attended our webinars recently, we have these wall packs that are up at the top, the WP LED, and its two form factors, the smaller one and the bigger one, the two slims up at the top. Primarily these four that are on the top here are shining the light down. Some of the wall packs do have the ability to angle them out a bit, but there's a difference between these four wall packs that are at the top and these four wall packs that are down below. Now, going along with what Bob and Donald were talking from area lighting standpoint, we need to concern ourselves with the fixture spacing. So Donald, when you talk about fixture spacing for a wall pack, what are good rules of thumb?
So as you can see on this slide, we're looking at a mounting height of X. In this case, let's say we're talking about 10 feet. And so we're probably going to look at about 3 times in between the fixtures. So that would be 10-foot mounting height, 30-foot spacing in between the fixtures. And you're probably going to put a forward throw out of that of, maybe 2.5 times the mounting height, depending on the distribution type.
Now, conversely, just like we were talking about a throw with area lights, we have a certain throw with wall packs too. What's the recommendation, or what's the rule of thumb for when you mount a wall pack up on the wall? How much forward throw are you going to get?
So again, it depends on the distribution type, but if you're looking at a full cutoff fixture and you're looking at a type 3, you're probably looking at about 2 times the mounting height out to the front, maybe 1.5 times. A type 4, you might get 2.5 to 3 times at that mounting height. If you go to the full glass lens, the non-cutoff type fixture, now you might get 3 times out from the mounting height. The challenge there, though, is that you're now starting to introduce light into the night sky. You're starting to impact the dark sky and are certainly introducing glare to the situation.
And we're going to be talking a little bit more about that later, but before we actually get to talking about some of those concepts that Don just talked about, we're actually going to talk about floods and spots, and I'm going to turn it back over to Bob.
Okay, good deal. So let's go through here and talk about our floods and spots here. So as we go through here, and let me just touch this so we can get it going again. So here's go back to here's the different fixtures that RAB offers. So you'll see up at the top, some of these, for instance, the Leslie only comes in a 6x6 distribution, and we're going to introduce that in just a few minutes. But it's kind of like a floodlight, bullet's a wide floodlight, and so forth. And then you get into some variations of the different way the beam comes out. You've got your X34 super economy version, the PIP, the FF LED, and you start to introduce some options there. And then the easy LED is 2 spotlight distributions, and then the FX is a wide variety of up to 5 or 6 distributions. So as we go forward, I'm going to introduce this just a few minutes and then ask Don to take over. So what I want to say is, if you'll notice this chart, this comes from the IES, and you have these beam types. This is a NEMA classification. Sorry, it comes from NEMA, and so National Electrical Manufacturers Association. And you see 1, 2, 3, 4, 5, 6, 7. So 7 different beam types. Each one of those has an associated angle, and then you have an associated distance that it will project. Now, if you look up at the top, you'll see the narrow beams, or the spotlights, the lower numbers, send the light further. And then as you get into the larger beam types, 4, 5, 6, 7, you'll see that they don't go as far, but the beam is wider. So with that, let's just uncover these 3. And Donald, I'm going to ask you to cover these 3 beam types here and tell us a little bit about what does 7 and 6 mean here and so forth, please.
Sure. Before I jump into that, one thing I wanted to point out, if you saw the large number of floods on our previous slide, RAB has one of the most extensive collection of floodlights of any manufacturer. We have something for just about every application you could imagine, from a small sign, small spotlights, up to 500-watt floods that you can light up sports fields with, and so forth. So we definitely have majored in flood lighting. Now, in terms of the NEMA classification, so as Bob was pointing out, the narrower beams are the NEMA 1, 2, 3, etc. And what this beam type describes is the field angle in degrees for first the horizontal distribution and then the vertical distribution. So you'll see over here on the left where it says 7x6 parking lot building facade. That's telling us that it's a NEMA 7 distribution in the horizontal and a NEMA 6 distribution in the vertical. So the 6 is 100 to 130 degrees, and the 7 is 130 degrees right up to 180 and beyond if they can squeeze it out. So each one of these, as you can see, they're broken down into about 11 or somewhere around 9 or 10 degree ranges. So 10 to 18, 18 to 29, 29 to 46. They vary a little bit as you go up. And so you could have a NEMA 3 that is 29 degrees and a NEMA 3 that is 46 degrees. So if you're really concerned about having a tight spot, you want to look closely at what the actual field angle is for that fixture. And you can see that the distance of this projects out. If I have a 3x3, I can project 175 to 200 feet. If I have a 7x6, I'm projecting out to somewhere around 80 feet. So if I'm going to light up a parking lot, a nice wide 7x6 is going to be a really good choice. If I'm lighting up a building facade, nice wide distribution, keep the fixture a little bit closer, it's a good option. If I have to be 200 feet away from the building and I want to light up a sign on the side of the building, maybe I'm looking at a NEMA 3x3. Something like that. That's kind of how you have to pick and choose. For sports lighting, we'll use a little bit of everything. We'll use a 7x6 to lighten the near edge of the field. We'll use a 5x5 to push the light out a little bit further into the field, and a 3x3 even further. We'll overlap them to get good uniformity. So each one of these has its place. The 6x4 works really well for a sign. It's, the distribution is shaped essentially the same as the sign. 4 foot tall, 6 foot wide, kind of equates to that 4x6 distribution. And then in terms of how bright do you want it or how far away would be the wattage that you apply.
Okay. All right. So we're going to go into our rules of thumb again. So this one focuses on this same type of rule of thumb. My favorite really here, this is for wide angle floodlights. So what we consider wide angle is a 6x6, a 7x6, and a 7x7. That's our definition of wide angle. So these rules of thumb work for this. So you see the 2x and then 4x in between the poles, 2x to the other side. And so you'll see this is what we call a perimeter. So we're on the perimeter of the parking area, non-corner pole locations. This is somewhat typical. And probably have more of these than we do the corner, but I just wanted you to note that this is where the poles are located, not in the corners of the, and so, and it goes 2x across. Now, if we also see 2x with a floodlight aimed at 45 degrees, but if we raise that to 60 degrees, we can go up to 3 times the mounting height. But as Donald mentioned, whenever you raise that above 45 degrees, you interject glare. So you get something, you get a little further distance, but you also get glare moved into the equation. Now let's go over and next talk about the, if we put 2 fixtures per pole. All right, so what happens here? So do we change the spacing between the fixtures? Actually, we don't. We're just covering, and what we're doing is really just improving the uniformity. So if we have a 2 fixtures per pole, same location, you have more fixtures, so you have more light and improved uniformity. But the rules of thumb of the 2X and 4X, 2X out 45 degrees, 3X out 60 degrees, do not change. However, what does change is, you see, when we have this application right here, where we have corner pole spacing. So Donald, if you would, tell us a little bit about the corner pole versus the non-corner pole applications, and which one is best, and why do you use what?
So best is always a very subjective term. It's which one provides you the light that you need where you need it. If I'm doing a car dealership, usually the front line, I need a lot of light on the front line to make the display row pop. And so I'll be using double-headed fixtures going down the length of the row. And when I get to the ends, I'm going to throw in a pole on each corner to really fill in on the very end so the cars really pop out. In sports, I might do a lot of 2 fixtures or 3 fixtures per pole, but I'm going to do mostly those along the sides and probably not too much in the corners, simply because we try and reserve the ends and the corners to keep light out of the player's eyes. So if we try and uniformly space it along the sides, then the players are all being uniformly blinded, if you will. You start to put it in the end zone and people can't see when they're trying to kick a ball or defend a goal or something, that becomes a problem. So probably more in terms of car dealerships and other applications like that, where the focus is on the object that's being lit. In sports, the focus is on trying to have enough light to see a ball traveling through the air or something like that.
Okay. So just for your general applications where maybe you're putting up 2, 3, 4, 6 floodlights and so forth. So some of the things that we just talked about. So you may want to use the corner locations where if you're concerned about darkness in a corner, and that works for that application. You may want to consider 2 floodlights per pole if you want to improve your uniformity and evenness. Then you want to say, typically aim the floodlights around 45 degrees, but if you need to stretch it a little bit, you can stretch it a little bit, but you're going to give up some glare. So that's some pretty good things to remember for just general parking. Now, when we go to the 4, we don't see this too much in floodlighting today. And 20 years ago, or maybe more, we did see floodlighting in center applications, except the one exception would be high mast lighting, where you use a type of floodlighting and you maybe use 4 or more pictures per pole. So you want to speak a little bit to this one, Donald, please.
Sure. So similar to what we were talking about with the area lights, you're going to light up the center of a parking lot. You've got large areas that you're going to try and light up, 30, 40-foot poles or whatever, and you're going to put multiple floods up there. Again, you're not trying to tilt these things up 60 degrees or 70 degrees or 80 degrees. You're trying to just get nice uniform spread from a high source, and the flood might be what you have the most output in or something like that. So we're looking at here, we're saying 4 times the mounting height when you have them tilted at 45 degrees, 6 times the mounting height when you have them aimed at 60. And again, you're getting that trade-off of glare for increased distribution and spacing. One of the reasons why we don't see this as much is because LEDs have really come into their own in terms of area lights and distributions, and you can do a really nice job in a parking lot with an area light, where a flood might be the choice that you had 20, 30 years ago. Now you can accomplish it nicely with an area light.
So if some of you are riding around and you see a floodlight and you're aimed straight up and down like this, you know that you're wasting a lot of light. You're not being effective. You're polluting the sky. And so if you just tilt that down 45 degrees, you'll do a much better job. So that's just a little thing to remember. So then the building facade. This is an interesting situation. So again, we have our X, except instead of a pole, these fixtures are mounted on the ground. So the distance or the setback from the building becomes kind of like our pole. So that's that distance we're going to talk about. So if we come off 1X off the building as our setback, we can go about 1 to the side and 1.5 to 2 in between. So let's look at an example here. So if we have a 15-foot setback, we can go and cover 15 feet to the left of the ground mounted flood. And then between poles, we can anywhere between about 22 to 30 feet. We're good there, depending on whether you want to be a little conservative or whether you want to stretch it just a little bit. And then 15 feet to the right. So that's how that works. And then I'm going to ask Donald to talk a little bit about the aiming as far as how high up that facade you should aim, because I know Donald does a lot of these. So Donald, I'm going to please ask you to cover this one, please.
Sure. And one of the things I want to point out, for those of you that have used the Easy Layout tool, this is how you would apply the Easy Layout tool to doing a sign or a building facade, which is when you look at the mounting height in Easy Layout, you now think of that in terms of an offset. So it's the offset of the fixture to the building. So in this case, we're looking at a building that is, let's say, 30 feet high. And so we're going to mount the fixture, ideally 2/3 of that 30 foot. So that would be 20 feet out. And then we're going to target 2/3 up the height of the building or the sign. That's kind of the ideal sweet spot when you're lighting up a sign or a billboard or a wall, is that you look for aiming at about 2/3 of the way up. And that gives you the most even distribution across. And then as you can see in this image here, we're looking at about 1.5 times the mounting height. So if we're at, if the height is 30 foot, 1.5 times would be, actually it's the offset distance, excuse me. So we're 20 feet off, so that would be 25 feet in between each of those fixtures, and that should give you fairly good uniformity.
Yeah, so these are little rules of thumb that once you kind of get them in your head, they're pretty simple to remember. So you take that distance away, so you aim it up 2/3 the wall, and you come off, let's say if it's 20 feet, then it's 1.5 times, so it's 30 feet in between fixtures. So
I did want to point one other thing out, is we're showing two fixtures here, the canvas, which is a 6x4, which is a very uniform distribution in that rectangular shape.
Right.
And then we have the X34 and a 7x7. And one of the advantages of the 7x7, because it has such a wide vertical distribution, you can actually get away with moving it a little bit closer to the building and still doing a nice job lighting it up. So when you're stuck in a constraint where you can't get the fixture as far back as you'd like, looking at something like the X34 may help you solve your problem.
Has a little bit more forgiveness also. So yeah, and as well as moving it closer. So very good. Right. Okay, so next one is just a single. So many of you, you know, all I need is just one floodlight. So the same rules of thumb apply. You see here just one nice little 18 FFLED 18 does this job. Okay, so I'm going to turn it. We'll continue on with flagpole lighting. So flagpole is interesting. So the rules of thumb is 3 fixtures is really the best, and it's in a circle of 120 degrees from each other all the way around, like we see in the diagram. And also, if you need to use 2, then that's the next best. And 1 basically meets code. It's pretty common, but it really will not do the job as the wind changes directions, as the wind flies, like we see in this particular application. So the 3 at 120 is really the best application. And so if we look at the next product here, this is one of my favorites. It's our spotlight, and it has a 4x4 distribution, and it's good up to a 40-foot mounting height. Donald, you've done a lot of these, I'm sure, with designs. So would you pick it up from here and give us a little bit of commentary on that?
Sure. And one of the comments I would make is the first thing that we say about flagpole lighting is we talk about 3 at 120 degree spacing, but we also talk about the fixture should be offset 1/3 to 1/2 of the pole height. And the purpose of this is that you want to get the light as perpendicular to the flag as possible. Now you're lighting from the ground, so obviously you can't be perpendicular to the flag, but you do want to get it as perpendicular as possible. So if I put the fixture directly adjacent to the pole pointing straight up, I'm going to be doing essentially flag grazing. The only thing I'll be lighting is the few ripples that happen when the wind blows. But if I can pull it back, now I'm actually lighting the face of the flag.
Okay, so a third half the way up is really good to know, rather than just right under. Don't put it right under the flagpole.
Absolutely not. And that's a common thing people want to do. They want to put in-ground lights. We don't offer in-ground lights for a lot of reasons. But all that does is it shines light past the flag. And if the wind happens to blow it through the beam, wonderful. But with the HS LED 26 here and some of the other fixtures that we pointed out, you want something that's a NEMA 5x5 or less. We have 5x5 all the way down to a very tight 3x3 that you can really throw light up a good distance. And the purpose of this is that you need to be able to project the light as tightly as you can, so you're not lighting a lot beyond the flag and wasting light, but you're getting as much light on the flag as possible. This is why the wider distributions don't provide as good a light, because it never projects up as far as the light goes.
Okay, thank you, Donald. So let's see. So as far as our easy design practices go, Ben is going to come in and take it from here. So see you in a few.
All right, we have a couple other topics that we want to talk about. A lot of times people talk about the bug rating because it's fun to say. It's not really fun to say IES Luminaire classification system. That's what it really is. But what we have here we see on the screen here is we have a pole. It can actually be a wall pack too. We have the sphere that goes around that wall pack, or the sphere that goes around that light fixture, broken up into 10 separate zones of area. We can see there that the yellow refers to the backlight. The blue up at the top refers to the uplight. And then that green portion along the front refers to the forward light. Now, last I knew that bug isn't spelt BUF. So what in the heck, how do we get backlight, uplight, and G for glare? The B has to do with the backlight, but it only includes 3 of the 4 zones. It includes the high, the mid, the low. The up includes both of the up portions, the up high and then the up low. And when we get to the glare, and this is where the G comes from the bug rating, is glare is the 2 components for the high and the very high for the front, and the high and the very high for the back. So when we take that and we apply it to a fixture, what we have here is the backlight rating for a traditional fixture on the left, a 400 watt metal halide, and then we also have the bug rating for a LED on the right. Donald, when do you care about backlight and when do you not necessarily care about backlight? And sometimes maybe backlight could be a good thing. Tell us more.
Yeah, so backlight has traditionally been an issue with large sources, particularly HID, because it's very difficult to limit the backlight. And so reflectors were designed around the fact that we have it, so let's try and maximize it or minimize it however we could. Along a roadway, I may or may not want backlight, particularly if I'm in a residential area and I don't want to light up the houses that are along the road. I just want to light the road up. And so that would become kind of an issue. And that's where you'll see the LED provides a very distinct cutoff to the rear of the fixture. Typically about half the mounting height is a good rule of thumb for how much backlight you can limit to, either with the LED in its native design or with an HID with the house side shield. Now, where you might not be concerned about it, or may you want the backlight, is let's say I'm lighting up a parking lot, I'm putting the fixture in an island to the front of the island, and I'm trying to light up all the parking spaces adjacent to it. If I don't have any backlight, I've got no light in those parking spaces. So with the LED, you have to mount to the perimeter because you're limiting all the backlight. With the HID, you can push it out into an island and get more further into the parking lot with the forward throw and, you know, still cover the back of the parking lot. So again, one of the things that I like to say about doing lighting design with all these distribution shapes is it's like doing a puzzle. And you try and find the right shaped puzzle piece to cover the area that you're trying to light and match all the puzzle pieces overlapping slightly. So
Excellent. The next portion, the next thing that we have here is when we talk about the uplight rating. Some people might refer to this as light pollution. If we have our fixture and that lens is parallel to the ground, you're going to have an uplight rating of 0. Now, anytime you take that lens and you start angling that lens up a little bit where it's not perpendicular to the ground, you're going to get a little bit of an uplighting component. Donald, tell us more from an uplight standpoint. What's good, what's bad, what recommendations do we give? How do we use that?
So there's a group called the International Dark Sky Association, and they've come out with a proposal that basically says all light should be U0. All light should be full cutoff, no uplight whatsoever, and that this will help us maintain the dark skies and allow us to see the Milky Way at night and so forth. And that's, their premise is a good one to start with. The challenge is that there are times, particularly if you're lighting pathway lighting or parking lot lighting, where you actually need vertical illumination to see whether or not somebody's coming towards you. You need to be able to understand, see their face and recognize their demeanor. And so if all you have is downlight and you have no vertical illumination at all, you may have a very difficult time seeing people's faces because they'll be heavily in shadow. So you can't eliminate all uplight, you can't eliminate all vertical illumination, but to the extent possible, certainly we strive to. And so the U0 is a good indicator. Most of our area lights are full cutoff area lights with a few exceptions. And then you have, for example, the one on the right, which depending on if you use a 7.5 or 15 degree angle on that would have a U1 or a U2 or possibly even a U3. I'm not quite sure, but it's providing more forward throw, and it is providing some vertical illumination, which may be important.
Excellent. So the next one that we have here is the glare rating. To give everybody here on the webinar an idea, this is our WP LED 52, which is basically the same thing as our A LED 52. We see some of those rays in the 60 to 90 degree zone. We can see that this guy has a glare rating of G1. Put other things in perspective, our Slim 12, our Slim 18, and our Slim 26, we can see an application here of those Slim sitting on the wall. With those guys, the light is just really going down, great distribution, no light up, you get a G0 rating. Now here we have a rough idea of what the different glare ratings are for our different wall packs. It's nice and easy to see that those wall packs, their primary purpose of shining the light down is going to give us a G0 for the most part until you take that WP and you start angling it at that 7.5 degrees or the 15 degrees. Or if you take the larger Slim, and that has the ability to rotate that guy out 10 degrees also. And so we see that the glare ratings go up. When we look at the wall packs along the bottom, the ones that are shining out in all directions, we're seeing a fair amount of glare coming out of those, and we can see some of them having a large glare number. Donald, when do we care about glare and when do we not care about glare?
We should always care about glare. As a matter of fact, I think it was a couple of years ago, the president of the IES said that we've got enough lumen output now, glare should be our #1 concern. However, there are times when there are overriding factors. But, my preference is always for full cutoff area lights versus floods, full cutoff wall packs versus non-cutoff wall packs. But, if you're in the back of a shopping center, you'll find often that we have non-cutoff wall packs. Why? Because they cover a large area, they're inexpensive, they do the job. They get the light where everybody needs it to be. And usually there's a wall behind the building, so you're not impacting the neighbors so much. So it really comes down to where can you apply this technology that it's going to not trespass onto the neighbors, not offend others, but perhaps save you some money. So there's some trade-offs going back and forth. But again, from a lighting design perspective, I always prefer to go with the non-cutoff, or the full cutoff versus the non-cutoff.
The top row versus the bottom
Top row versus the bottom row, exactly.
Excellent. Okay, so these bug values, it's really hard to come up with like a panacea, something that works for everything, because the bug values are highly dependent upon municipal codes, depending upon the lighting zone, where the property line is, and what your application zones are. We do have some values here that kind of get you in the ballpark, but again, that's what this whole thing is about, right? For an area light, a B3, a U0, or U0, and a G3 gets you in the ballpark, but if one of these numbers over on the left, municipal code, zone, property line, or application goals, can easily change these good values that you see over on the right. So moving on to our next topic, Donald, what can you tell us about equivalency in terms of going from a traditional light source to an LED light source?
The first thing I will say is it is a challenge because every light source has its benefits and uniqueness, and none are exactly equivalent. So we try and look at, can I light the same task effectively when we start talking about equivalency? And so, for example, you see we talk about a 400 watt metal halide being roughly equivalent to 125 to 150 watt LED. And as the efficacies grow, these numbers will get lower and lower. But currently, if you consider about a third the wattage of the traditional HID source, you're probably going to be close in the ballpark. 250 watt metal halide, you're looking at a 75 to maybe 95 LED. You know, the idea is, can I provide the same area of coverage? Can I provide effective lighting that meets IES requirements? Not so much can I create the same hotspots, which weren't necessarily beneficial in the first place, but can I provide the same coverage? So, you know, if I'm looking at the 400 watt metal halide on a 25 or 30 foot pole and I replace it with 150 watt LED on a 25 to 30 foot pole, maybe my hotspot went from 10 or 15 foot candles down to 6 or 8 foot candles, but I'm covering the same area and I actually have better uniformity. And so in a lot of ways, I've improved the lighting rather than just continuing the sins of the past, if you will.
Yeah, so for me, those of you who have attended a webinar before, we talk a lot about uniformity. So sometimes you can actually get to that 1/3 the wattage if you're overlighted, or if there's a high uniformity, you could potentially reduce that wattage even more than that general 1/3 of the wattage, and potentially maybe even get down to the quarter of what the original traditional fixture was. Okay, so the last topic that we have here, Donald, has to do with light level overlap. What are we seeing in front of us right now, Donald?
This is a typical isometric distribution for a single fixture that you'll see on the side of our box or in a catalog or whatever. And this is, I like to refer to this as the old school way of communicating what the light's doing. The first thing you need to know is the numbers across the bottom and up the side of the grid are multiples of the mounting height. So we're looking at a LED 360 on a 35 foot mounting height. So the 1 is 1 times or 35 feet, 2 is 2 times or 70 feet, 3 is 3 times or 105 feet. So that kind of tells you how far out the light is being projected. So that 0.5 foot candle line is out to a little over 105 feet. Now, the benefit of this chart is that if I want to look, say, well, no, I want to know what it is at 25 feet. So at 25 feet, that 1 becomes 25, 2 becomes 50, 3 becomes 75. And my 0.5 times the multiplier down on the bottom of 1.4 becomes the new value at 75 feet, 4.5. If I look at the 1 foot candle times 1.4, that's telling me at 1.4 foot candles at like 60 feet out from the fixture.
So without pulling out a photometric report, pulling out an IS file, going to easy layout, we can use this layout here, or this isometric chart, and do something with it, right?
Absolutely. we can get a rough idea of, and this is actually the way things were done in the past. You would take and trace that and trace them all over your plan by hand. You can take and look at overlap. And here's another rule of thumb. In the old days, when all you were doing was overlaying templates on a plan, the idea was you would overlay the 0.5 foot candle lines, which would give you a 1 foot candle in the middle and give you 0.5s on the outsides. And you would be generally in the ballpark of having a 0.5 minimum on your parking lot.
Excellent. So here, when we talk about light levels add, and you can actually use these little templates to get a rough idea of what your spacing is going to need to be, what your light level is going to be, because the light levels add. All right, so we're at the end of our presentation here. The top takeaways that Bob mentioned at the very beginning is the first one, easy design practices will help you use RAB products correctly and reduce callbacks. The second one that we have here is proper fixture spacing. We've taught a lot about fixture spacing and also aiming and mounting height for wall packs, for area lights, and for floodlights. Doing that correctly will contribute to cost savings and lower energy use. And the last one that we have here is using that bug rating, the backlight, uplight, glare, along with glare control, equivalency, and talking about that overlap will help enable you to light it right. We do have a variety of different sales managers across the US. We have Scott Teague in the West, Matt Tietz in the Midwest, Frank Gaudio from Kentucky up to Maine, Adam around our metro areas, and Terry Crawley there in the Texas and the South regions that would be more than happy to talk to you more about the concepts that we talked today, both from a lighting standpoint and from a RAB product standpoint. From myself here in Boston, thank you for coming. Bob?
Yes, please. I hope this has been meaningful to you. It's a little bit different from anything that we've done this spring and beginning of summer, but it's definitely useful. So, and also Donald, thanks so much for being our guest presenter. You can see why Donald is the lead for our outdoors. So thanks again for coming. We have time for a little bit of a question.